I will review this quickly. The only thing I will tell you is to make sure you remember. Not the only thing I will tell you. Remember your placeholders. What is a placeholder? It holds the place. That's exactly what it does. If I have something like 5x to the 4th plus 6x squared plus 7, I'm missing some things there, right? I start with the highest power and I work my way down. So to hold the place, I'd need something that holds the place of the powers of 3. I've got the power of 2, and then I need something that holds the place of the x, and then y. I don't know, I guess she needed groceries too. Okay, so these are what we call placeholders. To hold the place of anything that's missing. So in this example, I had the exponent of 4, but I need every exponent from there down. So I was missing the 3, so I put a 0x3. I got the 2, I'm missing the 1, so I put a 0, and then I got the constant.
What was that thing where we do like
synthetic? We're going to talk about that too. Yeah.
Oh, yeah.
All right. Polynomial long division. This is called placeholders. So let's say I needed to divide. Now, are they all going to need placeholders? No. Oh my gosh, stop. Started my video, had a paper airplane going through it.
Wait, like,
Could be written like this. It might be written this way. How else might it be written? I think that's probably the only way you'll, yeah. And so when you set it up in a division problem, this number or this polynomial goes on the outside, and then inside will be what's on the top or the first one. So just make sure you know how to arrange this before you divide. Do I need any placeholders here before I start? No. No placeholders. So when we did it in Algebra 2, I ran an example alongside that was the regular. I don't know if you guys remember that whole lesson that day. I ran an example of regular long division along the side to show you how the steps coincided to the polynomial long division. We won't do all that this time. We'll just go through. Remember, we're always looking at the first term only. So what do you multiply 3x by in order to get 3x cubed? X squared, just x squared, right? So already got a 3. So what do I multiply this by to get 3x cubed? X squared, right? So I have to think about these being in columns, and I come to the squareds column and I put the x squared here. Do y'all remember this or not? Okay, when you're doing regular old long division, like 5 goes into 412. Your first step is, what do you multiply this by to get as close to this as you can, right? 8, and you put it above it. I just did the same thing. But I only look at this outside term. What do I multiply this by to get this? X squared, and so that's what goes here. Only the first term in the outside, yep. But now, same step as here, I would multiply around, right? I'm going to do the same thing, but now I have to use more than just the first term. I'm going to multiply it to everything. X squared times 3x, and then x squared times 2 is positive 2x squared. Now what do you do? If you were doing regular long division, what would you do? Subtract. So I'm going to subtract this, but not just the first one, I'm subtracting everything. So 3x cubed minus 3x cubed cancels. 5x squared minus 2x squared is what? 3x squared. Now what? Yep, bring down the 8x. And now the whole process starts all over again. What do you multiply 3x by to get 3x squared? Just an x, right? A positive x will do. So I put that in the x column. It's okay. And now multiply around. X times 3x and x times 2. And again, I subtract. So I'm constantly doing the same thing over and over and over. 3x squared minus 3x squared. 8x minus 2x. 6x. Bring down the next one. X times 2. You multiply it to everything on the outside. You need me to wait here just a second? Let you catch up a minute. Well, I'm still not quite done. I brought it down. 8x minus 2x. I subtracted 6x. Don't remember. So now I'm going to do it again. What do I multiply 3x by to get 6x? 2. I multiply it around. 2 times 3x and 2 times 2. And I subtract all of this. What do you do with the 3, Carter says? This is my remainder. And what do you do with the remainder?
R3.
No! You remember this. You do plus 3 divided by what's on the outside. So what you get when you divide these two polynomials is x squared plus x plus 2 plus 3 over 3x plus 2. What's on your desk? Want to do another one? Okay. Carter. First thing I hope you noticed is you need what? 2 placeholders. You're missing x squared and x. So outside is 2x squared plus x plus 1. What is the number or the term on the outside called? Do you remember? This is called the dividend. The answer is the quotient. What is this part? You're close. Divisor. Divisor. I think they asked you for some reason in your homework a couple times if the dividend is the and okay. Regardless, let's finish. All right, so inside I need to make Carter stop. 2x to the fourth minus x cubed plus 0x squared plus 0x minus 2. What do you multiply 2x squared by to get 2x to the fourth? X squared. It goes in the squareds column. I multiplied around, but it has to multiply to everybody. X squared times 2x squared is x squared times x is positive x to the third, and then x squared times 1 is x. All of this gets subtracted, not just one piece. 2x to the fourth minus 2x to the fourth is gone. Negative x cubed minus x cubed is what? Negative 2x cubed. 0x squared minus x squared, negative x squared. Bring down the next term. Because it's subtracting this. It's subtracting everything in there. Now what do I multiply 2x squared by to get negative 2x cubed? Negative x. How is what, Robert? What is x cubed minus x cubed? That minus sign goes to everything there. Negative x cubed minus x cubed. Negative x cubed minus x cubed. You with me? So it's negative what? Oh, you're talking about here. Yeah. All right, let's multiply around. Negative x times 2x squared is, I'm multiplying here around. Negative 2x cubed minus x squared minus x. But I have to subtract everything. So this cancels, and it leaves me just with x, and I drop down the next term. It's minus negative x. So what's the problem now? 0 minus negative x, yeah. So now I've reached the point where there's nothing else. There's nothing I can multiply this by that would give me this, right? That means I'm done, which means this is my remainder. And how do I interpret a remainder? Well, I just say plus, that's exactly right, 2x squared plus x plus 1. All right, is it coming back to you? It's all coming back. It's all coming back. Better say yeah, or I'm going to keep singing. Okay. Yeah. Then we talked about some special situations with polynomial division. Sometimes when we didn't have to be quite so involved in working these problems. Do you remember what that was? Synthetic division. But synthetic division only works in a certain situation. What is that situation? Uh-huh. Only when you divide by x minus some number or x plus some number can you use synthetic division. There can be no number in front and there can be no exponent. It's just x minus something or x plus something. For example, can I use synthetic division here? So I can use it here because it's just x minus a number. Over here, see, it was a polynomial. It's only when you're dividing by that, yes. It's only for the bottom part. Now, you still have to have placeholders here, so be very careful. In the case of this one, I don't need a placeholder, but your answer will be way, way wrong if you don't put placeholders in synthetic division. All right, so when we set it up, have y'all done synthetic division before? Did y'all do it? Okay. I was talking to them. Yeah. All right, so here's what we do. You take this number, but the opposite sign. It goes on the outside. Okay, so it's an upside down division sign. And you need enough room for 2 rows of numbers here. And this first row is just simply going to be your coefficients, including placeholders, of your first polynomial. So 3, 7, negative 20. I'm surprised you remember, Carter. All right, Carter, tell them what to do.
Drop down 3.
Okay. Okay, so you drop the first one. You multiply by what's on the outside. Okay, and then you do what? Subtract it? You add it. Then what? Okay, but tell them how we're going to interpret this.
3x squared plus 13x plus 6.
Oh, sorry, you still multiply here. Yes, Lucy. Say it again.
Oh, this is the R.
This is the remainder column. You always start the far right. Remainder constant x. If I had another column, x squared, another one cubed, right? So this would be, if I divide these, I get 3x plus 13 plus 6 is my remainder, and I put it over what I divided by. No, it's opposite sign outside. Yes, and it counts out from there. If it's a bigger, yeah. But we'll do another one. We'll do another one.
X minus something or plus?
That's right. Yep. And no coefficient on the x, no exponent on the x. If this was 3x minus 2, it wouldn't work. Other questions about that so far? Try this one. Yeah. It's okay. Yes. Absolutely. Want to do one like that? Bless you. Ooh, let's do this one. This is number 12 from your homework. Oh. Why all the it looks pretty easy.
You have to do it 8 times.
Oh, you need some placeholders there, right? Yeah. We gotta do factor and remainder theorem. It goes right along with this. Oh, it is. Sorry. Remainder, constant, x squared, x cubed, to the 4th, to the 5th, to the 6th, 7th. So whenever I divide this, it equals x to the 7th minus 2x to the 6th plus 4x to the 5th minus 8x to the 4th plus 16x cubed minus 32x squared plus 64x minus 128 plus 255 over x plus 6. Now I want you to do something. Okay. Tell me when you want to. No, I'm not going to do that. Okay. I'm going to say that f of x is x to the 8th minus 1. That's the top of that fraction. What happens if you plug negative 2 in here? Tell me what that equals. I hear 0. But not. Look, 2, 4, 8, 16, 32, 64. It's 256 minus 1. Why is that? That is kind of crazy. Do you think it works every time?
No, I'm not going to do that.
That's your precisely, Mag, precisely. Here, if f of x is 3x squared plus 7x minus 20, what is f of 2? It should be what? 6 is what I should get. Well, 3 times 2 squared That's 12 plus 14 minus 20. It'd be 26 minus 20, which is 6. So in fact, this is what it will always work. We didn't talk about this specifically in Algebra 2. So here's a little bit of new stuff. We used to. I don't know why we quit. This is what we call, it's got a great, brilliant name, the Remainder Theorem. Okay? And it just says that if you divide by x minus k, and k is any number you want to, right? You will always get the remainder will always be f of k. In other words, if you plug that k value in with that opposite sign, it will always give you the remainder. That's pretty cool though, right? How is that going to be useful? I'm glad you asked. Because it leads us into something very, very, very important that we talked about a whole lot in Algebra 2, which was what happens when this equals 0. What happens if, okay, so if I plug it in and I get 0, that means I have no remainder. And if I have no remainder, then what have I actually found? Somebody said it. A factor. And a factor is very important because that is how I am going to get my polynomial factored down completely. Also, if this gives me a factor, then that also tells me one more thing about k. What is it? A. You're exactly right. K is an x-intercept, also known as a 0, also known as a solution, all of those good things. This then is called the factor theorem. They go hand in hand. Those are your two new theorems. And they follow, if you understand synthetic division, they follow. You walk you through one of each that'll be in your homework, so you'll know how to do them. And then I'll be done. Y'all got that? All right, so the first set, you may have to do long division on some. If you can ever do synthetic, do synthetic. So let's see. I don't think I have to go over that. 1 through 12, most of them are synthetic, so they shouldn't take you long. Then you get to 13, and 13 says use the remainder theorem to find the remainder when f of x is divided by x minus k. And then they give you, I'll do 18 because usually the last ones are the hardest. They say f of x is x to the 5th minus 2x to the 4th plus 3x squared minus 20x plus 3, and k equals -1. Find the remainder if you divide by x minus k. But what does the remainder theorem say? You plug it in. Remainder theorem just says to plug in for the remainder, because it's divided by x minus a number. So for these, literally all you have to do, f of -1 equals, and that's going to give you your remainder. You need me to do this one? You don't have to, because this is just remainder theorem. They're just looking 1 through 12. You'll use all that. Once you hit 13, it just says use the remainder theorem to find the remainder. So that's just plug in. Nope, not even that on this. All you have to do is plug it in. So -1 to the 5th minus 2 times -1 to the 4th plus 3 times -1 squared, 20 times -1 plus 3. So -1 minus 2 plus 3 plus 20 plus 3. -3, -23. So that's the remainder. That is all it's asking. That's what it gave me. It gave me that and that. So those are just plugged in. And then you hit numbers 19 through 24. And I'll just do the last one because the last one's just the hardest. And it says, use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. And so it's x plus 1, 2x to the 10th minus x to the 9th plus x to the 8th plus x to the 7th plus 2x to the 6th minus 3. Is it a factor? So instead of actually dividing it all the way out, I can plug it in and see if the remainder is 0. That's all factor theorem says. So if this is f of x, I'm just going to do f of what? -1. Make sure you change that sign. Yes. They write it a little different. They just say, is this a factor of this? So all you're doing is plugging in, but this time you're looking to see if you get 0 or not. You're wanting to get 0. 0 means yes, it's a factor. Anything else means no. Yep, and I changed that sign. So this is going to be 2, -1 to the 10th minus -1 to the 9th plus -1 to the 8th, 7th plus 2 times -1 to the 6th minus 3. That's going to be positive. That's going to stay negative. That's going to be positive, negative, positive, minus 3. So that's 3, 4 minus 1 is 3, plus 2 is 5, minus 3 is 2. So no, x plus 1 is not a factor because it has a remainder when you divide it. You guys see what we're doing? Yes, only when dividing. Any other questions? Page 200, 1 through 24. We just did 2 of them. Most of them are fairly easy. Most of them are synthetic. You only have 1, 2, 3 long division on there. Everything else is synthetic or plug-in. So you should be able to finish before you leave.